We're continuing section 5.1 on troubleshooting, and we had previously, in our previous section, we looked at troubleshooting open circuits and troubleshooting shorted circuits. We're picking up now on effects of component tolerances. Because of aging or overheating, component values may change in an electrical circuit. If a component value has increased in resistance, then the effects would be similar to an open circuit. Now notice that it is similar to. Remember, when you have a circuit and there is a complete open, then the resistance across the component will be infinite. Now in this case, the resistance has increased, so the resistance has gone up, but not to the point where it is infinite. If a component has decreased in resistance, then the effects would be similar to a short. And again, the same idea with a short. You have, there is going to be zero resistance. In this case, if the component value has decreased, then we just have less ohms than it should be, but it is not to the point of being a short. Now, this is a summary for troubleshooting series circuits, and this picks up on the previous lesson that we looked at, and also the items we just mentioned just now. First of all, the type of defect, and remember we talked about an open circuit, and this is typically because a resistor or a component has just physically deteriorated. Either it's overcurrent and burned up, but you have the open circuit. The voltage with respect to ground, what should you read? And this is, you put a voltmeter into the circuit, you're measuring across that component with respect to ground. Okay, near or equal to the supply terminal on the same side of the defect. So in this case, measuring across that open, you would typically see the supply voltage because there's no current drops in the circuit. The voltage across the defect, the full supply. The voltage across other components, zero, because remember, with an open there is no current, and if there is no current, there will be no voltage. Okay, now the increased resistance, which is similar to an open. Now it's not the same thing as an open. An open is more severe. It is infinite resistance, where increased resistance is going to be larger resistance, but not infinite. Near or equal to the supply terminal on the same side of the effect. Now your text just puts the same voltage with respect to ground that you would see with an open. I would expect it to be a little bit less. In fact, the voltage across the defect here, it says, well, it has increased. So the voltage across the defect will increase, but you wouldn't see the full supply voltage. And the voltage across other components, notice it has decreased. And the reason that it has decreased is because the total R has gone up. And so if total resistance has gone up, the current has gone down, and so the voltage measured across these other components will be lower because there's a lower current. Okay, shorted, and this is the one we talked about in previous lesson. The voltage with respect to ground, near or equal to the supply terminal on the opposite side of the defect. And we talked about this, that the voltage would not equal the supply voltage, but it should be higher across every component, because every component now is going to have increased current, which will result in increased voltage, because the shorted component resistance is now out of the circuit. The voltage across the defect with a short should be zero. And the voltage across other components should go up, and it is for the opposite reason that the voltages went down here, because now the total resistance has gone down, the current is going up, the other resistances remain the same. So with the current going up, resistance remain the same, the voltage across other components will increase. Then decreased resistance. Now again, this is similar to this, but it is not quite as severe. And we'll see the same fault here. The voltage across the defect. Now notice with the decreased resistance, the voltage has decreased, but it isn't zero because there is still some resistance there. And the voltage across other components, it will increase, but it won't increase as much because there is still some resistance in that component. So this is a summary for troubleshooting of series circuits. Okay, circuit connectivity problems. In practice, circuit boards can develop defects. And these can take the form of opens, shorts, higher resistances, lower resistances, and these are the faults that we've previously discussed. When circuit board traces open or short, they are very difficult to repair since they are often within the layers of the circuit board. So if we have components just out in the open, they are relatively easy to identify and replace. But within a circuit board, oftentimes you'll have traces, and sometimes the failure will often be inside of a layer within the circuit board. That makes it very difficult to repair. Now, in this case, there are options, and one of the common options is that the entire board is simply discarded. Oftentimes, the cost of a new circuit board is less than the cost of repairing it, so the board is just discarded. Now, there are other options. Now, if this is a very expensive board, you might call upon the services of miniature component repair technicians, their function is to repair these kinds of things. And they would come into play in the effect that this is very high-end, very expensive equipment. They would go in and actually repair the circuit board internally. And sometimes these guys will come into play with obsolete equipment. Maybe you have some equipment, and I'm saying using the term obsolete because it's not manufactured anymore. You may have a very critical piece of equipment that you simply can't buy components for them or buy the replacement pieces because they simply aren't for sale. And so in this case, sometimes you would spend the money to repair it because there just simply aren't any to purchase. Okay, effects of power supply defects. The power supply can also be a source of defects that must be identified and corrected. A power supply that produces no output voltage is easy to identify. Well, if there's no, the system simply won't work because the power supply isn't producing any voltage, and that is relatively simple to diagnose. A power supply can also produce voltages that are incorrect. They can be higher, or they can be lower, or there can be no output. Power supplies, in fact, not just power supplies, but electronic systems in general, typically will have tolerances. In this case, since we're talking about a power supply, let's pretend that we have a power supply that's supposed to put out positive 15 volts. Well, typically there were going to be acceptable tolerances, and if there's, say, it's a 10% tolerance, this could be plus or minus 1.5 volts, and it still would be providing an acceptable voltage for use. So just because the voltage is a little bit lower, a little bit higher than it should be, doesn't necessarily mean that it is bad. But if it goes outside the tolerances, then of course something would need to be done. In some cases, a power supply trying to deliver more current than it is capable of will deliver a lower voltage. So in this case, we have potentially a power supply. Maybe the circuit it's supplying is something has gone wrong and is pulling more current than it should, or maybe poor design, and the power supply is just simply being asked to deliver more current than it is capable of. So this can also be a potential failure point. So in this section, we looked at effects of power supply defects. We looked at problems that can occur in circuit boards. We also considered a summary for troubleshooting series circuits, and then we looked at the effects of component tolerances, and this has to do with values of components changing in resistance, either going up or going down. So this concludes section 5.1.